Bismillahirrahmanirrahim. Let us go into another topic, the technique of integration. How to integrate function that contains radical. Okay, so we have the technique, what we call as the trigonometric substitution. Okay, let us look into it. So far, when we have the integral that contain radical, okay, we have had this under chapter 4.4. Okay, these are the integral of a that contains radical, and the answer is inverse trigonometry. And we're gonna look at more question of integrals that has radical like this. So under this topic, we are to learn on how to integrate, okay, some more radical in a format of a square minus x squared plus a squared. Okay, and the radical of x squared minus a squared, where a is the positive integer, x is the variable. So basically the technique here is where we are to use this Pythagorean identity and to get rid of the radical. Okay, so we need to have it in a form of the cosine square. We know that a square square root is a itself. So that is the idea, changing it first into this trigo power 2. So again, as we know last time in our basic algebra, whenever we have, let's say, a square square root, we can eliminate the radical, it becomes a. Okay, let's look at example. Okay, but before that, this is in our workbook page 251. This is some guideline, okay, on using the U substitution. Whenever we have this form of integral in a form of a square minus x square, so consider to set the variable x to be a sine theta. And if you have this format, the U substitution, consider to change x into a tangent theta. And if you have this format, consider to change the x as a secant theta. Later on, we are to simplify the trigonometry. So you might like to highlight this formula, okay, these few formulas, and somehow you need to memorize, okay, and also make sure that it is in your notes later on. Okay, so we're going to use this guideline when we are doing the work. Okay, for a start, let us look at the example 1 given in our workbook. This is an integral involving the radical in a format of a square minus x square. A is the constant, x is the variable. Let us check whether or not this answer is given in our formula list, a square minus x square square root. So compared to the formula given to us in our formula list, we only have 1 over a square minus u square, the variable. Okay, so it's different. So we cannot use this as our answer. So let's come back to the question. So we're going to do it another way, because the answer for our integral just now, the integral of a square minus x square square root, the answer is not given in our formula list. Okay, it's different. This is 1 over, this is the numerator value of the integral. Okay. So to get the value or the answer for this form, we are going to use a method what we call as the trigo substitution. Okay, it's not U substitution, it's the trigo substitution. We are to change our variable into trigonometry. But first, we are to compare to the guideline. If we have a radical form a square minus x square, this looks like the first form. So we should consider to change the x as a sine theta. So the first mark goes to changing your x into a. Our a is square root 6. A square is 6, meaning a is square root 6. Okay, a sine theta. So that will be the first mark. Okay. This is called a technique of trigo substitution. And then we are supposed to replace everything in terms of theta. Okay, so we are to differentiate. Okay, so you differentiate this thing. Square root sec derivative of the sine is cosine. And then you substitute the value. Okay, 6 minus just now the x square. This is our x square. And change as well our dx, which is this. Okay, so substitute. And then you are to simplify the work. Okay, for example, here we have 6 minus, as we square it, okay, becomes square root square, we get 6, okay, sine square. And over here, okay, how to get to this, I'm showing you here. You are supposed to factorize, okay, factorize. And then here we have a form of square root a multiply b. According to the law of radical, you can split the a multiplied by radical b. Okay, this is the law of radical. So you can split only for multiplication. Okay, yeah. So then we have square root times square root, which is the 6. And we are left with this thing. Okay, and cosine theta remains there. Right. Then for this part, you are supposed to get a square. Okay, you are to use Pythagorean identity. 1 minus sine square, or 1 minus sine square is cosine square. So change it into cosine square. Cosine square square root. Okay, here's the square root thing. So let me show it there. So we have to change. So here we get 6. Okay, you have to change this 1 minus sine square into cosine square. Cosine square square root is the cosine itself. So we do have that cosine at the back. So cosine times cosine, we get cosine square. Okay, correct. Okay, so until you can get the cosine square. Right, it's a long working. And then after that, here we are to integrate cosine power even number. So this is the guideline that we have had earlier under the previous chapter. Whenever you see the sine and cosine has even power, consider to use this formula of a double angle. So we change cosine square into cosine 2x plus 1 over 2. So half, or actually here they are using another identity. Instead of that, I think they are using another identity. How to get to this portion, how to get to this part, 2 sin theta cos theta. Let's look at another identity. You can either use this one, or like in this question, they're using another formula. Let's get the identity for cosine square theta. Let's look into our formula list. So let me recall you people back to the workbook page 238. Turn to your book. The cosine square that we left just now, we have done it earlier. Okay, so we have to use double angle formula like this just now. And then we have this. And then we can separate them like this. And we are to integrate term by term. Okay, here we have to use a simple u substitution. Right, so cosine u, integrating cosine u du is sine u, and replace that. So that is the answer. Let's put this answer. So basically we have done this earlier. So I'm going to put this answer for our example 1 just now. Okay, let's put this answer. Half x plus 1/4 sine 2x. So for the cosine power even number, let me do it here again for you. The guideline that we have had under the previous chapter, if you have sine and cosine have even power, do consider to use this double angle formula. Okay, so we change here our angle is theta, so 2x here to theta. So then we can separate them, or here 6 and 2 is simplify, we got 3, here we have cosine 2 theta plus 1. Basically you can integrate term by term, but for this one, to be able to read from our formula list, we need to simplify as a single variable. So we said use substitution, u as 2 theta, du on d theta is 2, so we replace d theta, du on 2, then we have a single cosine u. Integrating cosine u, we can easily read from the formula list, we get sine, okay, so 3 on 2, and then for this part, integrating 1 d theta is theta, okay, the same, I'm going to put it down later on. And here, okay, as we replace back the u is sine 2 theta. But if you notice, the answer here is a single theta. So what happened is, sine 2 theta, look into your formula list. Okay, sine 2 theta is 2 sine theta cos theta. Let me show it. So for the trigger identity given to you, sine 2 theta or sine 2a is 2 sine a cos a. This is so that we can read it as a single angle. Okay, so this is the formula that we need to code. So sine 2 theta is 2 sine theta cos theta. Alright, okay, so as we simplify this, 2 cancel off, we get 3 sine theta cos theta plus 3 theta plus c. Okay, that's the end. So that's the answer, 3 cos theta sine theta plus 3 theta plus c. Alright, so we have to got that. And you have to show this, all this thing. Okay, and to simplify this, an identity that you are using there. Right. Okay, but unfortunately, our variable given to us is not theta. We have to turn it back into x. And we are using trigo substitution. So how to get that square root 6 sine theta, which is dx? So up to that level, you have to get that x being square root 6 sine theta. And I say that sine theta, definition of the sine theta is x over square root 6. If this is your theta, playing with your Pythagoras theorem, okay, definitions of a trigonometry, definition of a sine is opposite on hypotenuse. Okay, opposite on hypotenuse. So this adjacent side, okay, is c square minus a square square root. So c square square root 6 square minus x square square root. So we get this side to be square root of 6 minus x square. And then from there we can read our cosine. So definition of a cosine is adjacent, this 6 minus x square square root over the hypotenuse. Right, so you have to get this one first correctly. M1, you are applying Pythagoras theorem there. And then after that, then you will replace your answer in terms of the x. Okay, fill up the number or the values of cosine theta. This is cosine theta. And sine theta. This is sine theta. And then 3. Here theta. How to get theta? So if sine theta is this, so meaning theta is the inverse of x on square root 6. So there. And last plus c. So you have to have all this M1 to be able to convert it back into your x values, applying Pythagoras theorem and the property of a trigonometry. And that will be your last answer. It's a long working. Let us count how many marks do this question carry. I counted there are 10 marks given for this long question. Okay. Okay, inshallah, let us do more.